G'day viewers, line voltage and phase voltage. What is it? What's the difference? Let me take you back a few years to when you went to college. The first week of your first block at college, you saw this. Let's say we've got 100 volts there, and if these were both the same size resistors, then we would have 50 volts across there and 50 volts across there. So we had the total supply voltage of 100 and we've got the individual voltage of 50. That was fine, that was easy to understand. But of course, what did we do after our first block of college? We went out, drank and killed all the brain cells that we just created. Let me show you another way to draw that, which will be a lot easier for you. Okay, so now we've got 415, and in this leg here we've got 240 and we've got 240, and of course another leg down here which will then go off to another phase. So here what we've got, our line voltage is our supply. And here we've got each, if this is a winding in a motor say, then each winding has to share that 415 volt. And so we've got 240 on this one, 240 on that one. That is our phase voltage. Now we all know, we all call it out in the field, phase to phase voltage and phase voltage. So line and phase is what you'll see in engineering books. So we know what phase voltage is. We know that's phase to earth. Line voltage is simply phase to phase. Just a different way of saying phase to phase voltage. So that, and the same principles applied. The same as what applied up here is what's applied down here. Of course that's DC, that there's AC, and so it's not like 240 plus 240 is going to add up to 480, and that's because of the 120 degree phase shift. That's another video. But that's the difference between line voltage and phase voltage. Same also with current. So you've got line current, phase current. And once again, the same principles up here. What was the constant in that? If we've got 2 amps here, we'll have 2 amps there, 2 amps there, 2 amps there. So current is the constant. So same with this. If this here is a motor connected in star, if there's 2 amps there, we'll have 2 amps through the whole thing. So in this instance, we've got not the voltage, we've got line current equals the phase current. This one up here, a little formula for that. You don't have to remember the formula. You can build it every time. So let's say you've got a phase voltage of 600 volts, and you were curious what on earth would be phase to phase. So you can actually work out your formula every time. You can revert it back to this. You know that within this system we've got 415 and 240. So if you were to say line voltage equals phase voltage, well, you know that's not right. Because in a delta circuit where it's parallel, yes, that would be correct. But in this system, if we've got a phase voltage of say 600 and we want to work out what would be the line voltage, well, we know that the normal system of 240, we've got to put something else in that formula. And of course it's 3-phase, so we've got to put the square root of 3. Now, do we multiply it by the square root of 3 or do we divide it by the square root of 3? Pretty easy, because you know that if we were to divide our phase current of 240 by the square root of 3, which is 1.732, it would make it an even smaller number. We know very well it doesn't go smaller. So straight away we know that we put the square root of 3 there, and so our phase voltage multiplied by the square root of 3 will give us our phase to phase voltage, what we call it in the field, or our line voltage. Hope it helps. See you tomorrow.